Greetings everyone. My name is Ishani Sharma. I am from Mandi. I have completed my graduation from VTC Mandi in 2020 with 80% marks. Now I am pursuing my MSc in botany in SPCPU Mandi. About my family, there are 5 members in my family: me, my grandfather, my father, my mother, and my elder brother. About my hobbies include stone painting, designing mehendi, and dancing. About my co curricular activities, I have participated in many declamation, essay writing, and slogan writing competitions. My strengths include I'm punctual, hardworking, and helpful. My weaknesses are I'm a gullible person, sometimes boring and selfish. My aim is to become a professor. Thank you. Now, moving on to my topic, that is classification of gymnosperms. So, firstly, we will discuss about the introduction to our topic, that is classification of gymnosperms. So you all know gymnosperms are small group of vascular plants that reproduce by means of exposed seeds or ovules. Theophrastus in 300 BC used the term gymnosperms for the first time for the plants with unprotected seeds in his book Enquiry into Plants. Gymnosperms have more than 70 genera and 725 species. According to Raizada and Sahani in 1966, there were 16 genera and 53 species of living gymnosperms in India. The gymnosperms originated in late Carboniferous period. The lower gymnosperms, that is cycadales, show resemblances with higher cryptogams, whereas higher gymnosperms, that is Nitales and Coniferales, they resemble members of Angiosperm. Thus, gymnosperms form a bridge between pteridophytes and Angiosperms. So, orders that are extinct are Chorditales, Pteridospermales, that is also known as Cycadophylicales, Cycadiodales, that are also called Benititales. Orders that have living and fossil genera are Cycadales, Gingoales, and Coniferales. Sequoia gigantea is known as father of forest. It is world's tallest tree with 100-meter height, and it lives for 4,000 years. Living fossil is known as Ginkgo biloba. Now, there's a table. So it says that Cycadophylicales appeared in Carboniferous period. Cycadiodales flourished in early Mesozoic era. Chorditales were well developed in late Paleozoic and early Mesozoic era. Cycadales originated in upper Triassic period of Mesozoic era, but cycadales flourished in Jurassic period of Mesozoic era. Gingoales flourished in Mesozoic era, and it is characterized by only one living species, that is Ginkgo biloba. Coniferales appeared in at end of Carboniferous period, and it has about 52 living species. Nitales, that is the most recent group, it has 3 living genera, that is Nitum, Ephedra, Welwitschia. Robert Brown in 1827 separated the gymnosperms from angiosperms on the basis of unprotected or naked seed, and then he placed them in a separate group. So we will discuss about Pilger classification first. So Pilger in 1954, he divided gymnosperms into 3 classes. So these classes were Cycadopsida, Coniferopsida, and Nitopsida. He further divided class Cycadopsida into 4 orders, that is Pteridospermales, that are fossils, Benititales, that are again fossils, pentoxylates that are fossils, and psychedales that contains fossil and living genera. Coniferopsida class is further divided into four orders, that is chordatates, coniferales, texales, and gingoales. Last class, that is Nitopsida, it is divided into only single order, that is Nitales. So starting from class first, that is Cycadopsida. So characters of Cycadopsida class, they are typically xerophytes, strictly dioecious. Plants are palm or fern like. Stem is short, slender, and unbranched. Leaves are pinnately compound and arranged in terminal crown. Wood is monoxylic. So, monoxylic wood is the wood that has less xylem tracheids and more parenchyma. It has wide cortex and pith. Strobili are simple. Male gametes are motile. Ovules are unitegmic and seeds have radial symmetry. So Cycadopsida is further divided into four orders. So first order is Pteridospermales. It has fossils of moderate size. They have slender stem and presence of leaf gap in it. Frond-like leaves bears the scatosporangia. There is dichotomous open venation. Cupule in ovules help in reproduction. Pteridospermales is divided into further 7 families, that is Lignopteridaceae, Calamophytaceae, Glossopteridaceae, Medullosaceae, Catoniaceae, and Coristopermaceae and Peltaspermaceae. So I have made a mnemonics for these 7 families, that is mad cat lying calm on the carpet near glassy plates. Mad cat lying calm on the carpet near glassy plates. So mad is Medullosaceae, cat Catoniaceae, lying Lignopteridaceae, carpet Coristopermaceae, glassy Glossopteridaceae, and plates Peltaspermaceae. Next order is order Cycadiodales, that is also known as Benititales. It has fossils with tree-like habit. They are dioecious. Stem is short, stout, and covered with leaf bases. Leaves are large and pinnately compound. They have well developed cortex and pith is large. Secondary wood is again monoxylic, dicotyledonous embryo. Reproductive structures are borne on small lateral shoots. Microsporophylls are loosely arranged and megasporophylls are cone-like. They have bisporate sporangiate synangia. Cycadiodales are divided into 3 families, that is Williamsoniaceae, example Williamsonia, Villandelaceae, and Cycadiodaceae. Next order is order Pentoxylales. It includes only one family, that is Pentoxylaceae. Fossils with shrubby habit or a small tree-like. Leaves are simple, lanceolate, thick, spirally arranged with leaf traces. Stem is polystylic and they have 6 steels arranged in a ring. Wood is pycnoxylic. Male reproductive organs are borne terminally on dwarf shoots with branch sporangiophores arranged in whorls and fused basally to form a disc. Female reproductive organs consist of many cones that are spirally arranged on peduncle, each bearing many ovules on central axis with no megasporophylls or ovuliferous scales, etc. Seeds are sessile.
and ovules integument remain free from nucellus. Stomata were thought to be syndetochilic, but now they are considered to be haplochilic, and haplochilic development is guard cells are derived from the single mother cell and subsidiary cells are derived from different initials. Next order is Cycadales. It contains two families, that is Nilsoniaceae and Cycadaceae. Cycadales have palm-like habit. Stem is unbranched and monostelic, thick, slow-growing and columnar. Leaves are large pinnately compound. They have distinct midrib. Examples are Cycas and Stringeria. Young leaves show circinate venation. Leaf traces are diploxylic, that is, it has centrifugal and centripetal xylem. They have girdle shaped leaf traces. Microsporophylls are grouped to form male cones and they are large. They are scale like or peltate like Zamia, and pollen sacs are found on abaxial side, that is lower side. Male cones are terminal except Macrozamia. In Macrozamia, the male cones are present in axil of leaves. Wood is monoxylic. Megasporophylls are aggregated to form female cones except Cycas. In Cycas, megasporophylls are loosely arranged in form of crown at top of plant. They are spirally arranged. Sperms are motile and flagellated. Seeds are large. Example Cycas. Next class is Coniferopsida. So its characters are plants are comparatively large. Leaves are simple, that is they may be needle or scale like. Branch stem, wood without vessels. Resin canals are present. Pollen grains may be winged. Non-motile sperms. Female flowers are arranged in cones or catkins except Texaceae, Podocarpaceae and Cephalotaxaceae. Each flower has a bract, that is sterile portion, and a scale, that is fertile portion. Polyembryony is quite common. Cotyledons are apigeal, that is they grow above ground, and seeds have bilateral symmetry. Wood is pycnoxylic and it has well developed cortex. The wood is pycnoxylic and it has poorly developed cortex and pith. So first order of class Coniferopsida is Chordataceae. It includes three families: Aristophytaceae, Poroxylaceae and Chordataceae. They are fossil tall plants with slender stems. Stem bear crown of branches. Leaves are simple, spirally arranged and strap shaped, that is they resemble Orochariaceae and Podocarpaceae family. Leaves can be grass like with paler venation. Wood is again pycnoxylic. Sperms have not been reported, but presence of pollen chamber suggests that motile sperms have been formed. Reproductive organs aggregate to form cones. They have compound strobili. Chordataceae were abundant during Permian and became extinct in end of Triassic mass extinction. Single integument is there with three distinct layers in ovule. Next order is Coniferales. Plants are shrubs or large trees. Stems with profuse. Coniferales has dimorphic branching, that is long shoots which bear only scale leaves and dwarf shoots which bear needle shaped leaves. Resin canals are present in cortex and they are rarely in wood and leaves. Male cones are small and short lived and are arranged as compact clusters. Sperms are non motile. Female cones are compound and bear compactly arranged bracts scales, each supported by ovuliferous scale around central axis. Embryos are one or two or more. Secondary wood is pycnoxylic and vessels are absent. It has 9 families, that is Libaceaceae, Pelecygaceae, Pinaceae, Orocariaceae, Volziaceae, Cupressaceae, Podocarpaceae, Cephalotaxaceae and Taxodiaceae. I have made a mnemonic, that is latex plant Pinus arise from volatile compound Cephalotaxa. Latex plant Pinus arise from volatile compound Cephalotaxa. Latex say Libaceaceae and Taxodiaceae. Plant say Pelecygaceae. Pinus pinaceae. Arise Orocariaceae. Volatile Volziaceae. Compound COM say Cupressaceae. Pound say Podocarpaceae. And last, that is Cephalotaxa, that is Cephalotaxaceae. Next order is order Taxales. It includes only one family, that is Taxaceae. Plants are shrubs or small trees with branched woody stems. Leaves are small, linear and spirally arranged. Resin canals are absent. Microsporangiophores are scale-like or peltate with 2 to 8 pollen sacs which are arranged to form a small cone. Ovules are solitary and supported by decussate bracts. Embryo has 2 cotyledons. Next order is Ginkgoales. It consists of 2 families, that is Trichopitaceae and Ginkgoaceae. Ginkgoales order have plants that are medium-sized trees. Stem is branched and differentiated into long and short shoots. Leaves are leathery, strap-like or fan-shaped. They are commonly bilobed with dichotomous venation. Catkin-like male organs are axillary, bearing microsporangiophores. Each possess 2 to 12 pendulous microsporangia. Spermatozoids are motile and contain spiral bands of flagella. Ovules are terminal or axillary, about 2 to 10 in number, and seeds are large sized. So last class is Nitopsida, and its characters are they are mainly climbing shrubs. Stem is branched. Leaves are elliptical, strap-like or scale-like, that is they are reduced. Woods have vessels. Dioecious, they are dioecious except in some Netum species they are also monoecious. Reproductive organs form compound strobili or cones. Male organs are with perianth and enterophores, each with 1 to 8 synangia. Female organ is with single erect ovule. They have wingless pollen grains. Nucellus is surrounded by 2-3 envelopes. Micropyle projects as a long tube. An embryo has 2 cotyledons. Order Nitales. The characters are similar to Nitopsida class. The Nitales order have 3 families, that is Ephidraceae, Nitaceae and Welwitschia. Microsporangia are born in synangia, and Welwitschia synangia resemble Xylotum synangia. Welwitschia is represented by only one living species, that is Welwitschia mirabilis. Stomatal development is syndactylic. There is high degree of polyembryony and they have dicotyledonous embryo. Last class is Progymnospermopsida. Members of this class are not truly gymnosperms. They are thought to form a link between Xylophytopsida, that is pteridophytes, and gymnosperms. Formerly, they were thought to be primophilicales, that is pteridophytes again, but now they are considered to be nearer to gymnosperms after the discovery of the connections between gymnosperm-like trunk of Chelyxylon and fern-like fronds of Archaeopteryx. In some classifications, they are still treated as pteridophytes. Class Progymnospermopsida has woody extinct spore bearing plants. Vascular cambium with unlimited growth. Monopodial growth is present. Wood is pycnoxylic and mainly secondary wood. They flourished in mid to late Devonian period. They have frond-like leaves and fertile branches bear sporangia. Its first order is petioles. They are complex and they have lateral organs and compact xylem. Probable ancestors of conifers. They have fan-shaped leaflets. Example is Chelyxylon and Archaeopteryx. Branches were borne spirally and forked stipule at base. Fertile branches leaves were replaced by sporangia. Next order is Neurophytales. They have complex pinnate lateral organs. Pycnoxylic wood is there showing small medullary rays. They are probable ancestors of cycads. Example is Neurophyton. Lateral branches are arranged in loose spiral and some branches bore terminal clusters of sporangia. Next order is Protopetales. It is represented by only one fossil genus, that is Protopetales. Diploxylic leaf traces like cycads. Pycnoxylic wood like conifers. They are thought to be probable ancestors of gymnosperms other than cycads and conifers. So now conclusion of the whole topic. First one is Pilger et al. In 1954 divided gymnosperms into three classes, that is Cycadopsida, Coniferopsida and Nitopsida. Further, Cycadopsida is divided into four orders: Pteridospermales, Bennytitales, Pentoxylales and Cycadales. And these orders are further divided into seven families: three families of Bennytitales, one family of Pentoxylales, two families of Cycadales. Coniferopsida is divided into four orders, that is Chorditales, Coniferales, Texales and Gingoales. And they are further divided into families, that is Chorditales is divided into three families, Coniferales is divided into nine families, Texales is divided into one family and Gingoales into two families. Nitopsida is divided into only one order, that is Nitales, and it has three families. Next is Sandra Holmes in 1986 divided gymnosperms into four classes, that is Cycadopsida, Coniferopsida, Nitopsida and Progymnospermopsida under the division Spermatophyta. Cycadopsida is subdivided into six orders, namely Lignopteridales, Ketoniales, Bennytitales, Pentoxylales, Cycadales and Nilsoniales. Coniferopsida is divided into five orders, that is Gingoales, Chorditales, Coniferales, Voltziales and Texales. Nitopsida class is divided into three orders, that is Ephedrales, Nitales and Velvetiales. And the last class, that is Progymnospermopsida, is subdivided into three orders, namely Petales, Neurophytales and Protopetales. Thank you.